Hey everybody, welcome back. Today I'm going to take on the top 10 most frequently asked questions. And these are questions that I've seen in our videos. It's questions that get emailed to us. I even get some phone calls of people asking some of these questions. And I may have missed one or two that are pretty good, but I felt like these are the top questions that I just keep getting asked over and over. And so I thought, you know what? Let's have some fun. Let's address a bunch of these questions, and maybe I can squelch a little bit of this and head off some of these that just get repeated over and over. So let's have some fun. Let's look at what's going on here. And yes, I can barely see these things. I should have just printed these off bigger, but I did at least make a list this time instead of it just being right off the top of my head. First question: when are you going to get a better place to film? I like that question. I do have something in the works. We've got new construction going on over at the shop, and I'm going to have a nice dedicated area and a little space there with a little backdrop or something where things are a little brighter. I know this room is a little dark. All this stuff back here are the things that we take to shows when we do room treatment at a show, and it is more of a darker look because we always had light on the speakers and on the gear. And we didn't want it to just be a bright room. We wanted it to brighten up, put the light focused on what we're bringing in. So it's always been kind of dark, and it looks kind of dark in here, but at least I show up in the video. And I know sometimes the speakers don't show up very well that I'm trying to talk about, but we'll get all that fixed soon and try to bring the production capabilities up just a little bit. But for now, this will work, especially for a video like this one today. Next question. Why don't you listen to speakers that are sent in? That's a good question, and there's multiple reasons for that. First of all, customers send in a speaker for us to do upgrades on them. They just send one speaker, and that's all we really need. So I don't have the ability to listen to, nor do I care, to be honest with you. And the reason I say that is, even if I had a pair of them here, I'm not a reviewer. My job isn't to give feedback on how these speakers sound. They've been sent in for a reason, and it's my job to provide for that customer performance upgrades to that speaker. So what we're looking for when those things come in are just clear, audible problems. And those problems can be amplitude issues where like the tweeter's playing way higher than the woofer, or there's phase issues and there's a hole in the response. Or maybe the woofer's being allowed to play up too high and there's ringing and breakup in the woofer's cone. Or the cabinets are always buzzing. All those budget level speakers are really lightly constructed. The cabinets are buzzing. We're fixing clear, audible issues that we can measure and see and know that, all right, there's problems here, here, and here. Let's design a new crossover that fixes this, and then let's improve the quality of the parts, because let's face it, most of the time when that stuff gets sent in, the parts quality is horrible. It's super cheesy parts, so we're going in and designing something that not only fixes issues, but that brings the quality up to much higher levels. So clarity, detail, imaging, things like that. We're affecting it in those areas. So those are all known givens. And there's no need for me to then go back and listen to it before and after. It's kind of like bringing your car in to the auto shop and saying, my brakes are out. And I look at your brake pads and I say, yeah, your brakes are out. Your pads are completely wore out. I'm surprised you didn't run through the wall when you drove it into the garage here. We see that the brakes are wore out, and I know that it needs the brakes replaced. I don't need to take it for a test drive to figure that out. It's the same way with the speakers. Speakers' amplitude's all jacked up. The drivers are out of phase. We see things that we know are problems. I don't need to go listen to that to know it's a problem. I can see that it's a problem. So we don't need to listen to the pair when they're sent in. And when we do those upgrades and we send those kits out to the customer, the customer puts it together themselves. We still don't need to listen to it. We're not designing a new product. We're not tweaking this thing to the nth degree. We're fixing known problems and giving the customer back something that is much easier for them to listen to and more enjoyable to listen to. So, and for not a lot of money, by the way, too. Most of those upgrades are really cheap. Do you make all speakers sound the same? I get that a lot because more often than not, when I'm designing a new crossover for a speaker, we're going in and making adjustments within the amplitude, and we're balancing out the response. And people see that every time, like, oh, he just flattened the response. He just flattened the response. He's just making all the speakers sound the same. No, not even close. An accurate frequency response is a measurement of its accuracy. It really has nothing to do with how it sounds other than the balance of the speaker. I mean, it's just a measure of amplitude. That means how loud it is over a given frequency. And that is barely even a drop in the bucket when it comes to how a speaker sounds. There are so many more attributes that are going on that are time domain related or that involve cabinet resonances that we're correcting and a whole bunch of things that completely change how it sounds from one way to another that really has nothing to do with the amplitude at all. And especially when we get into better connectors, where we're getting ferrous parts out of the signal path, higher quality wire that's not old and oxidized, better quality parts. I mean, we're changing it in very intangible ways when it comes to measurements. We're changing it in how it sounds, three-dimensionally, layered, placement within soundstage, spatial cues, a whole bunch of things that you don't see in that measurement. All you're seeing in the amplitude response is just accuracy. And a speaker can have an accurate frequency response with garbage level parts in there, and it can sound dull and flat and lifeless, and you may not ever want to listen to it. Or it can be the complete opposite of that. It can be really fun to listen to, super dynamic, super transparent, super layered. You know, all those things can be completely separate and different from one another, and they can both have a very accurate frequency response. So keep in mind, frequency response, just a measure of accuracy. That doesn't tell you how the speaker's going to sound. Now, next one. Do you only like your own speakers? I get that a lot. Yeah, man, our speakers are the best. Everybody else's are garbage. That seems to be what people think when they watch our videos. Nothing really could be further from the truth, though. There are a lot of speakers out there that sound fantastic that I had nothing to do with and that I like. But the speakers that are sent in for a reason. They usually have problems, and I'm having to go in and make corrections and solve problems and design new crossovers and things like that. And there's a lot of times that speakers come in and they're generally just built to a price point, and so the parts quality and stuff is pretty poor because they just don't have any budget to spend on them. But they may have been engineered and designed really well. And I'll give you some examples. And I've said this in videos. When something comes in and it's really well engineered, I usually say this was really well engineered. It was just built to a price point. The ELAC speakers, for instance, and Emotiva, both of those are targeting the cheapest budget level of the industry. Like they don't cost anything. Really well designed. There's just no money spent in the parts, and you can only go so far with no money spent on that stuff, but well engineered. Golden Ear audio stuff, also pretty well engineered, measures really well, built to a price point. Spatial audio stuff, I've said many times, I love the way their stuff sounds. I've not done upgrades on that stuff, but when I hear it at shows, Clayton's come by, I've listened to speakers that he's designed. We're kind of on the same level as far as things that we're shooting for and things that we're listening for, and his speakers always sound really well. ATC, praised those a couple times. We've done upgrades on those speakers, but the driver quality has been really good. The engineering and the design of the crossover is usually really good. It's just a little bit built to a price point, a little soft on top. You know, we go in and we do whatever the customer's wanting us to do with that stuff and bring those resolution levels up to a little higher level by going to some little higher quality parts in there. So The Heiko speakers were well designed, and I mentioned that in the videos, as well as the MoFi products. Andrew Jones does a great job engineering that stuff. Again, built to a price point, parts quality left a little bit to be desired, soundstage a little flat, a little lifeless, kind of dull because of it, but it didn't take much to, swap in a few parts and change a few things that didn't change the frequency response, but it really brought the clarity and detail levels up and improved imaging. But overall, I liked the design of those speakers. And also is the Monolith series speakers that have come in. I've done upgrades on those. They were built to a price point, but again, really well engineered. So, and there's times I go to shows and I'll listen to some nice Von Schweikerts, or I've heard some of the Magicos that are set up really well, treated rooms. Yeah, they do sound good. And but it's all about really how well they're set up and the treatment in the room and things like that really go a long way in those things. And so, yeah, there's a lot of great sounding speakers out there that are not mine. Let's see. Let me get this on again so I can read this a little more clearly. Why no before and after sound clips? Man, that's a good question. Sound clips bring up a whole can of worms there. And I know a lot of the internet guys are trying to do sound clips and things, but it's really difficult. I've worked with Ron Bernay on figuring out how to make good sound clips. And I have to say, Ron's sound clips by far are some of the best sounding sound clips there are. The techniques that he's using and the quality of the recording devices and the way he's setting that stuff up, he's really getting some great captures. But when you play those sound clips back, especially over a compressed YouTube file, it loses everything. Like all the things that we're hearing live, like when we're sitting there listening to the speaker and we're hearing space and separation within the soundstage, that's all gone when you listen to it on a sound clip. The sound clips don't capture that. And when you play it back through your headphones or on your system, what you're hearing are the headphones in your system. You're not hearing what we heard when we actually took the sound clips. It's completely different. So the sound clips are good at detail levels, resolution, clarity, tonal balance, things like that, but it completely loses the whole sound stage and what's going on in the sound stage. That's just completely gone. So a lot of the time when we do an upgrade, like when we did an upgrade on the MoFi speaker, for instance, we're going in and replicating the exact same crossover, but with higher quality parts. And so the difference is, oh man, the sound stage opened up. There's so much more depth. There's so much more clarity and stuff. And it changed everything, but we didn't change the parts. It measures the same as it did before. So in a sound clip, all you really notice is just some of the clarity difference, and that's it. So you're missing 80% of what the upgrade is. Another reason I don't do the sound clips on stuff is I'd have to have a pair of the speakers sent in, and we'd have to measure that pair of speakers. And then after the upgrade is designed, I'd have to build out both pairs of speakers, and then we'd have to go through the whole thing again. I don't build out the speakers. When we design upgrades for stuff, it's a DIY upgrade. I give you everything you need to go and upgrade that speaker. You do it yourself. We do not have time to do assembly work and putting stuff together. I mean, my guys that work for me are busy just filling orders. Orders come in, they're pulling parts, putting them in a box, and there may be 15 or 20 orders going out in a day. If I pull Hobbs off of doing what he does and have him actually put crossovers together, I would really lose money. I just can't. I can't change what we're doing in that we're doing now assembly work. We go broke doing assembly work. But we have to leave that for the customer. So we don't ever have a before set of speakers and an after set of speakers to do the measurements on or to do sound clips on. It doesn't make any sense. We can't go down that road. If we started doing all of that, and if I started revoicing the speaker after I design an upgrade and go in and start listening to it and tweaking it and doing things that we would do if we were designing a product, you couldn't afford the upgrade. I'd have to charge so much for all that time that it wouldn't make any sense. I'm basically, when I do the upgrades, I'm giving away all my time for free. I'm doing all the design work and not charging for it most of the time. And I'm just selling you the parts that you need. And, in hopes that there's other guys out there maybe with that same model who will want that same upgrade. And then over time, I make up my lost time that I spent doing the upgrade and stuff. So, yeah, sound clips before and after, man, that's really tough. That makes no sense for me to provide that. But Ron and I are still working on some new techniques for sound clips, and we're working on ways to capture a little bit more of what we're hearing when we're listening. So stay with us and we'll see where that goes. There's definitely some development still there, and we'll see what happens on that one. Let me look at the next question here. Why don't you show measurements below 200 hertz? And there's several reasons for this. And let's start with speakers that come in for upgrades. What's going on with that speaker below 200 hertz? I can't adjust. It is what it is. And it's all a matter of the airspace in the box and the port tuning and everything like that. That's a given. That's a fix. So for me to spend time looking at what it is doesn't make any sense. I'm usually looking at everything that's above that range and balancing out the amplitude and balancing out the balance, or balancing the step loss, and doing crossover design work that involves everything that's above that. So what's going on below that, I can't really do anything about. And even with our own products, what I do is I can look at the tuning frequency and change the port tuning, and I can calculate where that 3 dB down point is going to be based on the airspace in the box. I can then do an impedance sweep, and I can confirm that it's tuned properly. And then we'll typically set a speaker up in the room and do a room response and see where it's rolling off. But we don't publish room response measurements because that's a measurement of the room. It's not a measurement of the speaker. Even though we're looking at, the room is a fixed variable here where every speaker that we bring in and set in the same spot, we're still getting a good means of comparison. But to say that this is what the speaker 3 dB down's at would vary depending on all the different rooms. So it doesn't make any sense for us to do a room response. And it also, when we're looking at a measurement like that at 1 watt, 1 meter, we can only accurately measure down to about 200 hertz. To measure accurately lower than that, the microphone has to get further away because those wavelengths are longer. And then you can't gate out the room reflection because the mic gets further away. You're going to see the floor and ceiling reflections and stuff in the measurement. And so we have to do a gated time window, and that means we have to get up a little bit closer. So it's almost impossible to do. And back when I had an anechoic chamber at my other location, we could do real accurate measurements down to about 40 hertz or so. But again, it didn't really make a lot of sense. We're really more focused on everything from a couple of 100 hertz and up. That's where we have some latitude as far as how to control those things and how to manipulate the response. Everything going on below doesn't make sense. Now, there are ways that we can take a near field measurement and splice it in, and we've done stuff like that before. We did that on the Brute model, and if you can see it on our website, you can see the response with that spliced in. So what that means is we take the mic and we put it right at the woofer, and we take a near field measurement and we see where it naturally rolls off, and then we try to splice it in with the response that I've taken that's 200 hertz and above, so that we can get a full picture of what's going on. And that works pretty well on a speaker like the Brute. That's a sealed box. But when you get into a ported box where you've got output from the port that's also contributing to the low end extension, then you have to take a near field of the port, and then you have to adjust the levels, like where do I splice this in? And it's very inaccurate. There's no consistency there. Even John Atkinson does this at Stereophile. He'll take a 1 watt, 1 meter measurement basically to get a reference, and then he'll do a near field of the woofer, a near field of the port, and then he'll add those together and it'll splice in some, And usually on all of his, it creates a big hump at the bottom. You'll see in the lower frequency range, you'll see this big broad peaks that are up there that are not really indicative of the speaker. All that's indicative of how it was spliced in, so, and it's different from room to room. That port output is on the back. So how much gain do you get depends on how close it is to the wall and how well the room's treated, and a whole bunch of factors determine what that low end is actually going to do. And splicing in a near field measurement like that sometimes is a little bit misleading. So it's something I just avoid doing. I don't want to mislead somebody into thinking, this is going to be 3 dB down at 50 hertz in your room, and then you put it in your room and it's 3 dB down at 40, or it's 3 dB down at 60, and it depends on where that speaker is in the room and where your gains and your peaks are, and it could be anything. So we can give a calculated 3 dB down on all the kits that we offer. If you look in the specifications, it'll tell you kind of where that 3 dB down point is. But trying to measure that down there, it's very inconsistent, and I can literally make it look like anything I want. I could jack the low end up or pull it way down and give it a shelf, and none of that's really accurate. So it's almost kind of a guess as to what it's going to do and where to splice it in there and try and balance that out. So we just don't do it very often. And the only reason I did it with the Brute, when it's sealed, and it would play down pretty low, and I wanted to just go ahead and get where is it actually 3 dB down, speaker only with no room, and it didn't have a port to have to splice in. So that was the reason I did that one. And again, we can do that, but it just doesn't make any sense. What we're looking at is everything above that. That's what's important for us. Okay, double blind test. I always get asked about this, especially when we're talking about differences in parts quality, tube connectors, cables, all this stuff, blah, blah, blah. We always get the flat earth guys saying, yeah, double blind test will show that stuff doesn't make any difference at all, blah, blah, blah. Well, almost 100% of the time when we hear somebody say double blind test, they've never done A/B comparisons before. And I know that because if they did, they would know that doing a double blind test is pretty much impossible. Double blind means that the person doing the switching and the person doing the listening doesn't know which is which. Now, if you can imagine trying to swap out a pair of cables and you can't look at them, yeah, that doesn't work. The guy doing the switching always knows which is which. You have to know which is which in order to see it. And it doesn't make any difference for the person doing the listening whether or not the person that did the switching knows what's going on or not. So it does not make any sense. We do A/B comparisons all the time, and it doesn't have to be blind. And it doesn't even have to involve somebody else. Sometimes I'll do A/B comparisons. I'll just do it on my own because I'm listening for, let's say, capacitors. I've got 4 or 5 different capacitors, and I'm listening to the differences in those sounds. If it's a lateral move, it's a lateral move. There's no expectation of what's going to happen. If one sounds better than the other, it has to sound so much better that I immediately notice it, and I can say this sounds better than this other, and then assess did that bring any value to the table. In other words, is it worth something? Is there a difference in price? If not, go with the one that sounded the best. So I do lots and lots of comparative listening, and it's not hard to do, but double blind, no, you just can't do double blind. And if you did do double blind, how would you know which was which? How would you know which one you preferred if the guy doing the switching didn't know what he was switching and the guy doing the listening didn't know which was which? There has to be an answer in the end. The person doing the switching has to say, oh, you liked the first one? Well, the first one was this cable or this capacitor or whatever. There has to be something there. And when you're doing research like what we do, it doesn't make any difference whether or not that guy knows, and it doesn't even make any difference whether you know or not. It has to be an audible difference that's clear and repeatable, or it didn't make any difference. And sometimes we'll swap between two things and it's just a lateral move. And then even though there may be an expectation that one's going to be better than the other, and you listen and you think, No, there's just not much there. You have to be able to be objective and do that. So yeah, double blind test. Yeah, you guys have never done testing before. If you want to keep claiming double blind tests, that no, doesn't work that way. Okay, I get asked this often too. What's your best speaker, or what would be, your best one? I want to buy your best speaker. It depends on the application. Absolutely depends on the application. You know, for a desktop situation, you wouldn't want big 7-foot tall in extremes, and you couldn't put in extremes in a 10 by 10 room. And when I design a speaker, I try to design the best speaker possible for a specific application, not just a best speaker for in anything. That's tough. Some of the speakers that I design, like the ones we're doing with Ron at New Record Day, they're specific to having to be out in the room. It has to be treated like an open baffle speaker. Open baffle speakers the same way. They have to be treated differently and brought out into the room. You can't shove them up against a wall or anything like that. So there's speakers for home theater applications and for 2-channel applications. So, what's your best speaker? Well, it depends on your application. It's simple as that. Let's see what else I got here. Number 9. What does it cost for me to get my speakers upgraded? Man, I get asked that all the time. You know what? I don't know. I don't know what it's going to cost to get your speakers upgraded. I haven't looked at your speakers yet. I don't know what they are. I don't know what it's going to involve. I don't know how much time I'll have to spend on it doing design work. I don't know what those parts are going to end up being. I don't know what those parts are going to cost. It's almost like saying, what does it cost to get my car fixed? And the guy on the other end of the line doesn't know what kind of car you have. He doesn't know what's wrong with it. He doesn't know anything about it. There's no way of answering that question. You're going to have to send one of them in and let me measure and test it, see what it's doing. There's no charge for that, by the way. And then I will email you the measurements and say, here's what it's doing. Here's some options. Here's things you might want to consider, blah, blah, blah. And then we can go from there. But to say it's going to cost this amount of money or that amount of money, man, I don't know. Look at some of the upgrades that we've done in the past that maybe are similar, and that should give you a range of, where you want it to be. And then there's options of, do you go with a JB Polycap, which is a really good polycap, but it's fairly inexpensive compared to a Sonicap, which is a higher performance cap, but it's a lot more money. You can spend a lot of money or a little bit of money on parts quality depending on how far you want to take it. So there's no way of answering those questions. All right, number 10. And then there's a couple of sub-questions under number 10 here. So, can you design a crossover based on my drivers? That answer simply is no, I can't just design a crossover based on your drivers or your driver specs. You can't just send me the drivers. What am I going to do with the drivers? I can measure teal small parameters, but that doesn't tell me anything. The way I design and measure a crossover is that it has to be in the box that it's going to be in, because that determines the response of the drivers. How much surface area you have around the drivers determines its response. If you put it in a little narrow cabinet, you got a small woofer, you got baffle step loss coming in at 1100 hertz or 1000 hertz. If you got a big wide baffle, big woofer, that step loss may be at 300 or 400 hertz or something. And then you may have surface area around the other drivers that are contributing to the response. And you've got edge diffraction, you've got acoustic center spacing and voice coil offsets, and you may have some driver breakup and ringing going on that I have to account for. And there's just a whole bunch of things, not to even mention changes in the amplitude. One driver is much louder than the other, and the only way to design that crossover is to put a microphone right out there in front of that speaker and measure each individual driver and see what it's doing. And, that way I can start doing a crossover design. But if it's not here, not physically here, I can't do anything for you. I can't fix your speaker if it's not here. I can't measure it if it's not here. I can't do any design work on something that's not here. Just as simple as that. Sub-questions that are under this one. Let's take a look at those. How do you design your crossovers, and what software do you use to calculate the values? All right, let's just start with how do I design crossovers? I'll have the speaker set up on a stand or a lift table out in front of me to where I'm behind the speaker. I'm 3 feet behind the speaker. And the microphone is sitting out in front of the speaker. And I'm sitting in front of the computer and I'm taking measurements. And what I'll do is I'll have a speaker cable back there and I'll clip on the tweeter circuit or the mid or the woofer or whatever it is I'm measuring. I'll look at each individual driver response. Let's say I'll start with the woofer. It's at lowest sensitivity. And I will look at the frequency response and think, all right, it's an 8 ohm woofer. That's going to need about a 2 millihenry, 2.5 millihenry inductor. And to get it to roll off where it needs to be, about a 12 microfarad cap, maybe 15 microfarad cap. So I'll put the inductor on it. I'll shoot a measurement. I'll look at it and see what it's doing and think, you know what, I'm going to bump that to a 2.2 millihenry, and I'll swap it out, clip that on, shoot it again, look at it. Yeah, that's about right. Now let's put that 12 microfarad cap on there and shoot it again and take a look and see what it's doing and think, oh, you know what? I think I may go to a 15 mic cap. Drop that on there, just clip it on, shoot a response. I'm just looking at its amplitude and its curve at this point. And then I'll move to either the mid or the tweeter and look at the level and think, all right, that thing's 4 dB louder than it needs to be. Let's start with a 4 ohm resistor at the start of this because I'm going to wind up with some more resistance at the other end. Let's start there. Let's put a 4 ohm resistor at the front. Let's do an 8.2 microfarad cap, and let's see what the roll-off looks like. Okay, that looks pretty good. Let's go ahead and add a coil there, and let's put a 0.27 on it and clip that on there and take another measurement and watch what it's doing to the response. And I'm watching it in real time. I'm looking at it. I'm thinking in my head, what does it need? I'm physically putting it on there. I'm clipping it together with little jumper leads with alligator clips, and I'm taking a measurement and I'm watching exactly what's going on in real time. So I'm building this in real time. I am using my experience to know what parts are needed, and I'm not using any software to calculate anything. Nothing is simulated. It's all from experience. You'd be surprised it goes pretty quickly. I can see what it's doing, know what it needs, put it on there, shoot it again, then start shooting them together, seeing how they sum, deciding, do I need to do a different order filter in order to get these to sum? Do I need to push this crossover point one way or another? Are there breakup modes I've got to consider? Let's do an impedance measurement real quick and see what that's doing and see if there's a mismatch in impedance. I might need to adjust the resistor at the front of the tweeter circuit versus one I may have in shunt at the end to try and balance out the impedance. Let's go back now and see what they're doing independently and together, shoot another response, see how they sum. It's a little back and forth, knowing what I know and knowing which part to put on in order to get the desired frequency response. So it's pretty much all experience and just knowing what it needs and what it does, and then building it on the fly. And so when I'm done, the whole crossover is clipped together on the speaker, and I'm seeing that exact crossover on the speaker and the measurements of that speaker with that crossover on there. I'm not simulating anything. And then I'll document everything and write it all down. Once I've looked at the vertical off axis to make sure that the drivers are in phase over a wide range, I look at the horizontal off axis to see if there's peaks or dips or something going on because of edge diffraction or surface reflection, and do I need to address that? Do I need to go back to the on axis and soften it in an area where there's a peak in the off axis, or is it soft going up or down, or what is it doing? And then back and forth trying to create a nice even power response. In other words, an even response in all directions. And it's basically moving the microphone, or if it's on a stand, I can put a scaler right up on top of the speaker that shows 10-degree off axis in each direction, and I just simply rotate the speaker and leave the microphone where it is and look at the off axis responses pretty quickly. To go up and down, I have to go move the microphone 4 inches at a time, up or down, see what it's doing. And I'm constantly looking at spectral decays to see if there's some kind of breakup or anything going on, or maybe I'm getting a reflection inside the box that's due to not having enough insulation in it. I'll go in and add insulation, see if that controls what I'm seeing in the spectral decay. It's a lot of back and forth and just knowing what to do. That's how I design a crossover. So how about that? My top 10 most asked questions, and I'm sure there's some more questions out there. You guys can just throw them under this video. Let me have them, and I'll try to answer those questions. I hope this was helpful. I hope this helped you kind of understand how I design crossovers, what I do, what the goals are, and all that good stuff. So if you did like it, give me a thumbs up, and if you're new to my channel, please hit the subscribe button so you can know when new videos drop. And we'll see you guys in the next video.